Okay, yeah, thanks for the introduction. I can say a few things on the title slide. The first is maybe not everyone knows bi-intuitionistic logic. And my plan is to mostly excite you about this and talk about it from a perspective of constructive meta theory, trying to understand soundness and completeness results for that logic. But actually, the real main reason why we submitted that is because Ian, while he was still working in Australia, I was always annoying him. Maybe one day you come back to Europe and then you can come to the TYPES conference, because it was already mentioned a few times today that it's a cool conference, and I told him you will really love it and you will have fun there. And so he made it almost all the way. So now he's in Birmingham, but unfortunately he in the end couldn't make it here. So we try again next year in Gothenburg to bring it to the community, and instead so I will give the presentation here. But this is mostly about work that he has been doing in the time of his PhD studies and postdoc in Australia together with Katrin. So what is bi-intuitionistic logic? I don't assume everyone of you knows it. It is a logic kind of touched in the talk before because it has a certain modal character. And I can motivate it from one particular perspective already targeted to the algebraic understanding of it that I want to focus on in this talk. And so if you look in intuitionistic logic or most logics, you find this word also mentioned in Greg's talk, that adjoint appear for the interpretation, the connection of implication or conjunction. Also, there's the word of residuation. And now you can wonder if there's actually something dual to it, if there's a dual residuation result. And this would be the property for exclusion. So exclusion is kind of dual to implication, and that it commutes with disjunction on the other side of the turnstile. And then you can wonder what the study of such an operation would be. And if you do that in classical logic, everything is super boring, because there turns out that exclusion satisfying this property is nothing but phi and not psi, so a negated implication. So there's no additional structure. But it turns out if you do this in an intuitionistic-based logic, a lot of new structure arises. And actually, it's structure that kind of adds more symmetry to the logic, makes everything more dual. And so it's kind of neat to look and study this logic. And it has been studied mostly, usually this is connected to the work of Rauser that was conducted by a line of papers in the 70s, culminating in her PhD thesis. But then if you dig a bit deeper into the literature, you find that there were also precursors to it. The earliest we were able to trace was in Neusil's work from the 40s. And then kind of the story was ended. So Rauser's PhD thesis was, here is all the meta theory of bi-intuitionistic logic. But then something happened starting a bit more recent. There were a lot of errors found in that work. There were counterexamples to claim cut elimination results, counterexamples to disprove strategies for completeness, and so on. And so more recently, and a bit biased in the Australian bubble, is that a lot of people, in particular Ian, but also collaborators, looked into bi-intuitionistic logic again. But it's not only focused in Australia, also in Bochum, the group of Heinrich Wansing is looking into bi-intuitionistic logic. So there's a bit of more interest in it from recent years. And then I jumped onto it because I was interested as well in understanding this logic and seeing how the meta theory of it works out if we work in type theory and formalize everything. So now we can make things a bit more concrete. So basically what I will do is I give an overview of two papers that we have already out, and then one little additional observation we made towards the end of last year. The first work was concerned with propositional bi-intuitionistic logic. So this is really just adding exclusion as another primitive through the syntax of propositional logic. And then what you can do is already you see you have more symmetry. For instance, there's something dual to negation, which is the exclusion from true. And then suddenly this gives you a weak notion of negation, and you will see that if you throw, for historic reasons, a Hilbert calculus system on it, you notice that suddenly you have some certain behavior of interaction between these notions of negation. And in particular, you can find, if you symmetrize the notion of derivability, that you have these two residuation properties. So conjunction or addition of a formula on the left commutes with implication, and addition on of a formula on the right commutes with exclusion. And then things become provable, like you have a weak form of the excluded middle. Every formula satisfies high or weak negation of high. So this logic seems to be semi-classical in a sense, but if you look at the semantics, the usual way to look at would be quickly semantics, which is the usual idea of you having pre-ordered sets, you have a persistent interpretation for atoms, and then the interpretation is extended to exclusion, exactly dualizing the usual interpretation of implication. Implication normally looks in the future and checks that implication is forced in every accessible world. And here you say that at least in one previous world, the exclusion is ruled out. Or do you prove you force the premise and don't force the conclusion? And then you see, if you go through the semantics, that actually bi-intuitionistic logic still happens to be conservative over intuitionistic logic. So although you prove new formulas, including exclusion and weak negation, if you take a full turn by going through soundness from bi-intuitionistic logic and then to completeness to intuitionistic logic, you get conservativity. But because you have this weak notion of excluded middle in bi-intuitionistic logic, the soundness proof of it will not be constructive. In fact, the soundness of it is equivalent to the excluded middle. So that's a funny observation we made in the paper. Now, turning to the completeness question, the result we are after is if a formula is forced in all of these propositional Kripke models, then it should be derivable. And there, I already mentioned, so in Auser's work, there are some alleged completeness proofs, but already Polar noticed that something is fishy about it because she worked with rooted models where you have a root for the Kripke frame, but it was noticed that actually the logic cannot be complete for that notion of semantics by Polar. And so additionally, there was some confusion about the status of the deduction theorem and some other things about the logical primitives in the language. So then Ian and Rajiv worked on it together to fix the proof, and then we formalized it together, which is basically boiling down to the normal Kripke style simple canonical model construction, on which you then can do a bit more things. You can mechanize it in your table proof assistant, and you can observe in the style of what already, for instance, in work with Hugo was observed. You can see that completeness behaves inherently non-constructively. In particular, if you formulate completeness in a very well-suited way, it turns out it becomes equivalent to this logical principle, which we still don't have a better name for than the countable weak excluded middle shift. And that turns out to be just equivalent to completeness. Okay, so that is the first part I wanted to talk about. The second part is, well, if you can do propositional, could be interesting to do first order as well. So what you do is you add to the syntax first a term language as usual, and then you extend the propositions with universal and existential quantification. And then you do the same on the deduction system. If you're continuing Hilbert style, this means you have a few more axioms and a few more proof rules. And suddenly something funny happens, namely, you're not conservative anymore. This axiom is usually called the constant domain axioms. It allows you to pull out a disjunction out of the universal quantifier. It doesn't mention exclusion or weak negation, but it's suddenly provable if you have the proof rules of bi-intuitionistic logic. And the reason is basically because of this dual residuation, it allows you to flip parts of the disjunct or out of the disjunction into the context. But then this means kind of semantically you jumped into a previous world in which you can introduce a variable and suddenly you have more information available, and then the premise here suffices. So that's kind of a funny side effect. And it means that here the logic is not only kind of semi-classical, it's really not conservative of it. And so you can study the semantics of it, and because it satisfies the constant domain axiom, which for intuitionistic logic means that you are talking about Kripke frames with a constant domain. The canonical semantics to look at for first order bi-intuitionistic logic is also the one over constant domain. So you have a Kripke frame, but you have just a single domain at every world, and you evaluate in it. In particular, this means that the interpretation of quantifiers is fully local. You only have to look at one particular world. And then you can see that, well, you still are a conservative extension over constant domain intuitionistic logic if you do the round trip of soundness and completeness again. And for this, we had to look at the completeness theorem for bi-intuitionistic logic. There's a question in between. Excuse me? Sure. For soundness, still, you have also in first order logic this result. For completeness, I will explain that we don't have a clue what we need. So what we first did is, again, we found Rausser's proofs. They were already wrong for the propositional case. Then we found one earlier proof by Klemke, but that was a bit inaccessible to us, although it was in German and I happen to speak the language. It was in rather old German and a very difficult, say, technical presentation, and in other papers, errors of this were already stated. So we thought maybe it's better to start from scratch. And what we found out is that you can actually take your standard textbook proof for constant domain completeness and do a funny thing that you kind of dualize it. And dualizing means that you first observe that normal intuitionistic logic, there's an axiom which basically plays the dual role to the constant domain axiom, namely pulling out the conjunction out of an existential quantifier. And using this and then literally following the same proof, you can derive what usually is needed in these completeness proofs is Lindenbaum lemmas that allow you to jump into future worlds with extensions, particularly ruling out some formulas. You can now jump into previous worlds, ruling out some particular formulas. And this gives you the machinery to arrive at the completeness result, to be able to mechanize it in ROP because it's rather feasible. And then we use full classical logic because we don't have a clue how these Lindenbaum lemmas work because they are a bit more zigzag. And so the trick I knew from before didn't work. So this is open. Okay, so it was a bit unsatisfying. So in the last minutes, I explained that we then got interested in looking at algebraic semantics because normally there the completeness property or overall meta theory, also including soundness, is much more constructive. And what you have to do there is basically you follow the recipe that you know from propositional and intuitionistic first order logic. So you look at Heiting algebras. Heiting algebras mean these structures which exactly give you all necessary algebraic structure to interpret logical connectives. And then you add one additional connective, which exactly allows you to interpret exclusion. So nothing interesting is happening there. They are called bi-Heiting algebras usually. In those, if they are complete, you can not only interpret in the canonical fashion the propositional part, but by completeness, you have arbitrary needs, so you can also interpret the quantifiers purely syntactically, and in particular the atoms you can interpret fully syntactically if you have some interpretation that is algebra valued. And then fully constructively, straightforwardly, you derive the soundness results. Nothing is going on there. And the nice thing is, at least in the propositional case, also the completeness result is basically a no-brainer, because what you have to do is you follow the usual steps that you look at the Lindenbaum algebra, which is just the algebra connecting provability between formulas as the pre-order, and then you have the syntactic logical connectives and everything. It falls into place. It's easy to show that this is a bi-Heiting algebra once you have established nice proof rules. And then you observe that obviously by construction in this algebra formula is valid if and only if it is provable, and so you complete completeness. So this is all nice and easy. The only additional thing you have to do for first order logic, which is the thing we were stuck on a bit, is that you observe that the Lindenbaum algebra normally is not complete. So you have to use your usual completion that you can find from the independent study of completions of algebraic structures. Here we use the Dedekind-McNeil completion, and the lemma that we observe is that every bi-Heiting algebra embeds into a complete bi-Heiting algebra, which then gives us the completeness theorem for first order bi-intuitionistic logic. And the proof is a bit funny because what you normally do is you look at the sets of the subsets of the algebra that are closed, in the sense that if you take all the upper bounds and then all the lower bounds, you didn't change the set. You were still included in it. And then you can show by some standard arguments, first of all, that this is a complete lattice. So all the The lattice structure is trivial, and you have a canonical embedding by looking at the downsets. What is a bit more complicated is to define implication and exclusion. Implication is standard. You basically bake in the residuation result for implication that you flip with meets. And then for exclusion, we needed a while, but it was a nice coincidence that I had dinner with Marco Abadi at that time, who happened to know how these things work. So he told me at which points after dualizing without thinking, you have to put some upwards and downwards closures, and then in the end it worked out. So then with this result, you can make it by heighting. And as a corollary, you get the completeness theorem. And here, unfortunately, it looks a bit asymmetric, but that's only because we broke this symmetry in the beginning by saying we look at this particular closure. And we looked at it a bit afterwards again, and there's a nicer way how you can present it. If you instead look at pairs of sets, one being down-up close, one being up-down close, and then everything works out nicely because then you reestablish the whole symmetry. Okay, so this allows us to give a fully constructive completeness proof, which is kind of a bit more satisfying than the situation in model theoretic semantics. And with this, I conclude by saying that this is still some ongoing effort, and maybe at next year's types, Ian will be here and explain what we found out in the meantime. The things we want to understand crucially is what actually the constructive status of the quickly completeness proof is, because I have a feeling it might be full excluded middle, but on the other hand, it would be a bit surprising. Then these algebraic proofs, although they are nice because they are fully constructive, they only give you weak completeness, which means you only have finite context. And there are standard techniques how you can extend this into strong completeness, but those don't seem to be interacting well with this completion for bi-heighting algebras. So there's something to figure out. And then it's an interesting kind of open problem what the computational interpretation of exclusion is. And Polar has worked on it, and there are connections to linear logic, but I haven't understood much of that yet. And it seems to be that still people in Australia at least are working on that. So we're going to see how this is continuing. Okay, so thanks a lot for your attention. I'm looking forward to it.